So the next one is the tree diagram. Now the tree diagram is a systematic approach to outline and identify the tasks and methods needed to solve a problem, especially to reach our predefined goal. Now there are a couple of notes that we want to be sure of. The first one is that the objective is always noted on a card and placed on the far left side of the board. And then we have 3 different solutions are furnished to achieve each goal, and the solutions for each goal are provided. Now we did kind of talk about this earlier in the define phase, something called a CTQ tree. And a CTQ tree stands for critical to quality. And it's the same kind of idea in terms of what we're trying to solve a problem for. So let's say that we have a problem where we really need a cup of coffee, and that cup of coffee needs to be good. So we're going to say that we need a cup of coffee, and that coffee has to be good. So the next thing we have to look at is first off, how are we going to define the word good, which means we need to have these drivers set to help better explain what we mean by a good cup of coffee. So let's say that our first driver is that it has to be hot, but not too hot. Okay. Now our second driver is going to be that it needs to have a strong flavor. I like my coffee strong. If not, it's just coffee flavored water, right? And then we have the correct amount of sweetness. So I'm just going to put sweetness, right? Correct. So these are the drivers. So basically, driver 1, driver 2, and driver 3, if we meet all those drivers, we have a good cup of coffee. Okay? But still, we don't know how to get to where we need to be. So the first thing is how do we really define hot but not hot? How can we solve that problem? Well, we can solve it by looking at the temperature. Is the temperature correct? Right? Well, not only is the temperature correct for the water, but how about the milk? Because I like a little bit of milk with my coffee. And I like my milk cold when it goes into my hot cup of coffee. So then how about strong coffee flavor? Well, a couple of things we could look at, right? We could look at the amount of coffee grounds. So the amount of grounds. and if I could spell today. You can't really read that, but it says grounds. Right? And then the next one is the grind of the bean. Right? I like to grind my own beans. Well, what about if our sweetness is correct? Well, we need the right amount of sugar. And not only do we need the right amount of sugar, but we're also going to need the type of sugar or type of sweetener. Maybe that's better. Right? It might not be sugar, just a sweetener. Or all of these are ways that we could solve our good cup of coffee, because now these drivers now have things that we can actually measure. I can measure temperature. Temperature tells me if it's hot or not too hot. I can measure the amount of grounds and the type or grind of the bean. And based on that, it will tell me how strong the flavor is. I can also measure the type of sweeteners I have. I can categorize them. We could have Splenda, we could have Equal, we could have sugar, we could have honey, we could have stevia. And also the right amount of those sweeteners would give me the correct sweetness. So based upon those 6 things, it meets my 3 drivers, which in then turn will meet my need of a good cup of coffee. And that is the tree diagram. So prioritization matrices are used to prioritize a set of tasks or a set of product or service characteristics based on known weighted criteria. It is a method of decision making without using the computer. Now there are 3 types of prioritization matrices that we can use to develop. The first one is something called the full analytical criteria method. Then we have the consensus criteria method, and then the combination interrelationship matrix method. Let's review an example. So here's an example of something called the prioritization matrix. Now, using brainstorming, we're going to list down the criteria that is required for meeting the goal and to calculate its relative importance. Then we're going to list down the options to be compared against a weightage criteria, and we're going to calculate relative importance. We're going to calculate the relative importance for all other criteria. And in the full analytical, we're going to bring all of these matrices together. We're going to arrange the list in an L matrix and calculate the relative importance. With the highest value, we'll be getting our first priority. So in our first boxes, we notice that the first column is named criteria and then cost. And then we have resource availability, data availability, strategy fit, a total, and then our relative importance column. So when we start looking at all of these different things, we have to start applying a weight to them. And I would recommend that we use a weighting of between 0 and 10. And you can use decimals if you feel that there's a little bit of a weight, but not something that is significant. So let's look at our first X and Y. So our first X is cost, and our first Y is cost. So there's really nothing that we need to place in that particular box. Now, in terms of cost and resource availability, I'm going to put that as a 0.2, and then I'm going to use cost and data availability as 1. Cost and strategy fit is 0.1. We're going to add all of those together, and that's going to get us to 1.3 with a relative importance of 0.04. The next thing we're going to look at is resource availability. We know that cost is pretty high with resource availability, so we're going to label that as a 5. Then the next one that's going to be relative will be our data availability, and we're going to make that a 5 as well, because our data availability and our costs are going to be relatively equal to that of our resource availability. And then we'll put a strategy fit, we'll add it all together, and we'll get our total with a relative importance of 0.31. The next is our data availability, which will have all of those numbers populate, and then we'll have our strategy fit with all of those numbers populate, and then we'll add each column to find our relative importance and the total for each. We can do that again with strategy, with conforming, contamination, varnish, and all of these things.